This is project 3 video number 1, the pencil and paper part. We're supposed to find the voltage across R2 as a function of the value of R3. I've made a drawing of the circuit. Let's put the currents in there. You got one current here. I'll call that I. Oh, I forgot to put the subscript on R1. I think I'll call that, yeah, I's an okay name for it, but I'll go with I1, and then it splits up into I2 and I3, and then those guys rejoin here to form I1 again, and I1 is good all the way in this part of the circuit. I'm going to go ahead and label everything plus and minus now. Minus, plus. For the CWMF, current goes in the high side, falls down through the resistor, comes out the low side in every case. And I'll call this V2. This V3, the voltage across this resistor, and this V1. The first thing you should notice is that V2 and V3 are the same. Because the circuit only has 3 conductors. A red one, a blue, well, actually, I'll go a green one. So and a black one. Yeah, I guess we might as well make that a different color too. So let's try blue. So we got a red conductor, a green conductor, and a blue conductor. And V2 is the potential difference between the red conductor and the blue conductor. V3 is the potential difference between the red conductor and the blue conductor. The same 2 conductors. This whole conductor is at one value of potential. This whole red conductor is at another value of potential, and it doesn't matter whether you sample the potential difference here, where you would naturally call it V2, or you sample it here, where you would call it V3. We have V2 is equal to V3. You could get that very quickly by means of a loop that just starts right here on this red conductor, goes through R2, and then winds up back on the red conductor. You know, Kirchhoff's voltage law would read minus V2 plus V3 equals 0. From that, you immediately get V2 is equal to V3. Prefer that you solve that it's the potential difference between the same 2 conductors. It's older stuff, stuff that you learned earlier, more fundamental. And then V1 is the potential difference between the green conductor and the red conductor, so it's different. Now let's try the loop rule, and I've already got a relationship between the voltages, so we can pretend that I did that inner loop right there, and I'll do another loop. Usually I tend to, like if I did that inner loop, then I would do this loop, so I do all the inside loops, but that's the way I usually do it. This time I prefer to go around the outside, and I would say it's because I want V2. I'm solving for V2. I don't think it really makes much difference, but I feel like going around the outside this time. So this is my loop. I'll call that loop number 1, and KVL on 1 tells me, actually I want to be able to see that, so I'll write that. KVL1 plus V1, positive change in voltage as I go across the seat of EMF, or plus V, I'm sorry, plus V, and then minus V1 minus V2 equals 0. Alright, so that's one equation right there, and then I go try a junction rule. Kirchhoff's current law at A yields, I think I can call this equation 1, oops, equation 1, equation 2, and then this one says I'm going to go current in equals current out. And not sure I need to number that one. I usually work in terms of the currents. This time I'm going to try to get everything in terms of voltages. They're asking for a voltage. Doesn't really matter which way you go, but from Ohm's law, V is equal to IR. I have I is equal to V over R. So this becomes V1 was the current through R1. So this is V1 over R1 equals V2 over R2 plus V3 over R3. Now I'm going to use equation 1 to substitute for 3. I make that substitution, I get well, let's say it follows down this way. V1 over R1 equals V2 over R2 plus V2 over R3. So I'm trying to solve for V2 as a function of R3. Let's see if we have a way of kicking out V1. I think I'll use equation 2, solve for V1. Solve equation 2 for V1. And what's that give us here? V minus V2. Substitute into this equation. And I do that substitution and I get V minus V2 over R1 equals V2 over R2 plus V2 over R3. Now let's see if we can get all the V2s on one side of the equation. I'm going to multiply, or I'm going to add V2 over R1 to both sides. Well, let's go ahead and divide that R1 into each of these. V over R1 minus V2 over R1 equals V2 over R2 plus V2 over R3. And now I get all the V2s on one side of the equation, everything else on the other. So I got V2 I take that over to that side. I got v2 over r1 plus v2 over r2 plus v2 over r3 equals v over r1. So v2 times 1 over r1 plus 1 over r2 plus 1 over r3 is equal to v over r1. So v2 equals v times, multiply both sides by the reciprocal of this thing in the parentheses. So it's v over r1 times what you see in the parentheses there. So I think I'll distribute the r1 partially. So it's 1 plus r1 times 1 over r2 plus 1 over r3. Pretty clearly makes it clear that it's a voltage, because the bottom is unitless. I got 1 plus resistance times something that's got units of 1 over resistance. So let's see, by the way, if I increase R3, what happens to V2? If I increase R3, that makes this number right here bigger, which is going to make the denominator, it makes this number smaller. 1 over R3 becomes smaller. So that's going to make the denominator smaller, which is going to make V2 increase. Increase R3, V2 increases pretty well. Alright, so let's see what we're supposed to do. I think we're supposed to graph V2 as a function of R3. V, R1, and R2 are provided by the user. R3 is a variable, and we see what V2 looks like as a function of R3. Let's make sure that's the case. Returns nothing. Graph of voltage across R2, that's what I call V2, as a function of the value of R3. For R3 from 0 to 10 times R2. So I think my plan is going to be to let's see, I'll make I think I'll say what the function is, like I'm returning nothing. I think I'll call my return variable nothing. So function nothing equals, so I'm going to call it plot V2 of, and the project direction told me very specifically what I had to put in there, what the arguments were. V, R1, and R2 in that order. Okay. I'll go ahead and call them that. V, R1, and R2 in that order. So I'm going to try creating an array R3. I think I guess it's going to be obvious that it's an array. I'm going to try not calling it R3 array, but just R3. And that's equal linspace 0. See, here I'm telling the reader that we get these values, the value of V, the value of R1, and the value of R2 from the user. I'm going to call that not R subscript 2. I probably should have gone with that, but I'm going to go R2. Those are going to be my variable names. Linspace 0 up to 10 times R2. You know what? I'm so used to writing those things as subscripts, I'm actually going to go back the other way and make them all subscripts. Just when I program it up, they'll become the other. So this is R3. 10 times R2. And, well, and how many of them do I want? I think, let's try 100. And if it doesn't look smooth, I'll go 101. If it doesn't look smooth, I'm thinking of like, if R2 is 100, then it'll be 1 through 100 plus the 0 value. That's by 101 instead of 100. If it doesn't look smooth, then I can just bump up that number. And then 3, we just use this equation. And I go V2 equals V. I'm going to be dividing. I'm going to call it dot slash right here, even though this is just pseudocode, just my outline of how I'm going to do things, but just to remind me that I'm dividing by something that's an array of values rather than just a value. So I use dot slash, which says do that division element by element. And then 1 plus R1 times 1 slash R2 plus 1 slash R3. This is going to have to be a dot slash as well, because R3 is the array. Then I'm just adding numbers to it, so that's not a problem. I don't need a dot slash for just adding numbers. So what was that? 1 dot slash. Okay, this is 1 divided by R2. That's just a number. I'm adding a number to an array. That's okay. And then I'm multiplying an array by a value. That's okay. I'm adding a value to the array. That's okay. And then the division, I needed the dot. Alright, and then I'll go plot. I think I'll write it in lowercase just to remind me that that's got to be lowercase. And it was R3, comma, V2. That should do it. I'm going to call that a wrap for project 3 video 1.